Okay, in this week we will talk about the modeling of rigid body mechanics. This is our topics, okay? And so the purpose of this chapter are to what? First of all, the obtaining the equation of motion. What's the meaning of the equation of motion? Blue guy. So what's your name? Nasir. Nasir. So what is the definition of the equation of motion? For rotational and the translational motion. Huh? The equation of motion means that we have a dynamic which is motion, and so we can create what a differential equation about these terms, okay? And also we need to talk about the rotational and the translational motion. About what? About the mechanics, okay? What's the meaning of the rotational? Could you tell me? Yes, translational? Yes, Mr. We have a 1 point in here, we have a point but rotates, okay? And so, after all, in the second place, we need to apply the principles of conservation of mechanical energy, okay, in terms of the kinetic and potential one, okay? And also we need to talk about the concept of the equivalent mass and inertia, okay? What's the meaning of the equivalent here? What's your name? See, it's not the red one, it's the white. Okay, what's your name? Gülsüm. Gülsüm. What's the meaning of the equivalent mass inertia? Have you ever heard about anything about this? Okay, and so we will talk about it in this lesson. In order to what? In order to create our system dynamic model based on the what? The equation of motion, right? Because the motion means that the differential, right? For a given variable. So, in the first place, we need to talk about the motion types, guys. Motion types. First of all, we need to say that applying to Newton principles, we have the 3 dimension in here: Z, X, and Y. Also, we can put to what? To this mass value in here as a what? As a particle, okay? And so, in order to translate or obtain the motion about on this what? This mass, we need to put to what? Or apply the force value in here. Resulting of this force, we can generate what? The velocity value. On the what? On space, right? And so, the first law of the Newton principle states that rest or moving continue until to what? Until applying another force in here. Because it changes to the what? To the momentum of these terms, okay? In the second law, we need to say that the acceleration, just remember, thank you, acceleration is proportional with the what? With the what? Huh? No. Acceleration proportional with what? Just remember this F is equals to the what? The m times a, and so force, right? Force. But in terms of the vector in here, because if we have the 3D dimension, so we have v in here as a vector, because we have vx speed, vy speed, vz speed, right? Gülsüm? Is that okay with you? Everything is right in here up to now? Okay. So, in the third law, for the Newton's principle, states that what? Just tell me, what's your name? Yasser. Yasser. Can you tell me the third law? Yes. If we have the rigid body, so the force is equal to the what? The reaction, right? These are the basic rule. Because if we have the rigid body, and so if we put any force in here, and so reaction force must also be created. But when? When? What's the condition of the creating the reaction force? For example, I can put this value. Is there any reaction force in here? Huh? Reaction force?
Actually, yes.
Huh?
In your fingertips, there is actually.
But why?
Because you are trying to hold it.
Yes.
So you apply force
Huh?
on the bottle.
Yes, but the bottle is moving, right? If it's moving, and then there's no reaction force in here. For example, if I push this table, reaction force happen or not? Happens. Why? Because it still remains constant at the position of the what? The x, and so if we want to talk about the reaction, we need static system, right? Otherwise, we can accelerate. With respect to the what? Second law of the what? Of the Newton principle. Okay? So, what about this one? What's the meaning of the particle? Particle means that this is the negligible dimension, guys, okay? So, we can, or we only creating a force around the what? The rotational or the translational. Translational or the rotational occurs in the system, in the particle. Which type of motion can happen in this system on the particle? Why? Huh? Why? Who's talking? Yes?
Can't rotate.
Be-
It's around.
Why it can't rotate?
Because it's not fair dimension.
Yes. If you want to talk about the rotation, and so we need a dimension. Okay? And so, in this case, we can write that to what? M dv dt is equals to the f, or m d square x dt square is equals to the f. Okay? These are term, right? This is the x dot dot. Okay? Any question? Arkadaşlar bunu Türkçe söyleyeceğim. Lütfen bir daha derse geç kalırsanız ikinci ders gidin, tamam mı? Dikkatim dağılıyor. Okay? So, just like the, what's your name? Kadir. Kadir said, if you don't have any dimension, we must create the what? Translational motion. It can only happen in the system. But if we have to what? If the rigid body, not elastic one, has dimensions, then we can create the 3-dimension in here, just like this one, z, x, and y. And so we can put to what? An object or the rigid body in here. And so this point, just remember the static lesson, this is the cock, right? Center of gravity. And so if we apply any forces in here, just like this one, this is the r, and so this is also v value, but also we have rotation value, w, right? Okay, and so this body has both translational and rotational motion. To what? To preserve the shape of the body. What is the meaning of the preserving the shape of the body? Can anyone say that? Huh? Yes, no deformations, but if we don't have any deformations on the shape, and so we can rotate or translate. For example, if you are using what a spring, and so we cannot move this spring because it stores our energy form in here, right? Okay? So, okay. So, what about this one? If you put to what? F is the vertical of the what? The center of gravity, or is in the line. And so, in this case, which kind of motion can happen? Huh? Translation. But rotational? Why? Please be loud, guys. Loud, loud. Thank you. Arkadaşlar bağırın ya. Rahat rahat yani konuşun yani. Anladınız mı demek istediğim şey? Yanlış olsa bile yani. No rotational motion. Okay? So, how we can define or the model to the what? To the rotational motion. Just remember that if we have the F is equals to the what? The M d square x dt square. This is related to the what? Which kind of motion? Yes. How we can convert this equation into the rotational one? How we can do that? Huh? Yes, but F is replaced with the what? Moment. Yes. M0 is equals to the what? M should be changed with the what? Huh? Inertia. And so, this term replaced with the what? Huh? No. Omega, but the position, the angular position is the theta square, right? And so this M0 can be defined with what? F times R, right? This is the moment. Instance, if we apply the force with the what? With the value of the R, and so we can say that this could be created the moment, okay? So, if we want to build the analyze these values, and so we should also define the mechanical energy in here, just like this one. Okay. First of all, assume that F is a function of displacement. m times v dot is equals to the fx. Okay, and so this force value is what is defined with what, with the position value, the storage elements of the what, the mechanical one. Okay, and so just remember that in the mechanical system, if we have the any mass in here just like this one, and so we can put what, the f, and so we have also velocity value, but we can't create or destroy the energy, right? And so this mass contains the energy, and so we cannot destroy it or create it in the universe, right? And so in this case, this is preserving energy. Okay, this is preserving energy. Okay, so we can write these formulations in here just like this one. Remaining time in which v m dv is equals to the what, v dt f x, right? Because if we multiply this term with what, v times dt, and so if we multiply these terms also v times dv, we will get these equations in here. Okay, this is just simply the equation form. And so in this case, dx dt, which is equals to the what, velocity, right? And so fx in here and dt must be equals to the what, fx times dx. This is simple calculation of the what, rearranging the formula based on the what, based on these conditions. Okay, and so what about this one? If this is the fx function, as it is it the force, and so if we take the integral values of these terms, and so this gives us to the what, mv, this is the momentum value, and so momentum change in here, just like this one, this could be what, 1 divided by m times v square. This is equals to what, the kinetic energy, right? This is the proof of the kinetic energy. And also this function should be equals to the what, the fx dx plus c. In time, this is actually is equals to what, the potential energy. Okay, either we have the potential energy or the kinetic one, but we can convert the potential energy to the kinetic one, or the kinetic one to the potential energy. Okay, this is the basis of the what, the R theorem. And so this is the mechanical energy. And so we have two mechanical energy. One of them is what? Kinetic. The other one is the potential. Okay? And so, but where it comes from? It's the basic notion to drive this equation. Just see that if we have the m, and so if we have the v value, we can continue to preserve the v value. The speed of the m does not change, but it still has an energy. If we want to change the v value, and so we need to apply the force, right? And so if we change v, right, the action is applied. The general name of the what, the effects, is called the action. In this case, the action equals to the what? Equals to the what? No. Action. Yes. Who is that? What's your name? Bilal. Thank you for your participation. Bilal. So, Bilal is approved, yes, approves the R theory, and he said the action is equals to the what? The force, and so we can move this nomination. And so here, how we can interpret the what, the potential and the kinetic one. we have 3 dimension in here, okay? And this is the origin points, okay? And so we can say that if we have the m value in here, and so we may also have v value here, okay? We can define to the what? To the kinetic energy based on this term. But how we can define the potential one? The potential energy is defined in the definition with the deflection rate with respect to the what? To the your origin, okay? If we define the any system with the basis of the O or origin, okay? And so if we have the at the z direction at height value, and so we can define it has a potential, right? So it has a storage energy for me here. But how about this one? We can build the what? The another values in here, m, and also we have v, and O1 is equals to what? Another 3D dimension. And so if we have the any potential energy in here or not. Why? Yes. If we want to define the any origin values, to define our coordinates, if the r coordinates at always on the what? On the m position, and so we don't have the any potential energy in here, okay? So the potential energy is a general coordinate framework proof to the what? To the change of the kinetic energy one. So just see that if we have any v value in here, just like this one, the v, and so the direction is changed, okay? But at any case, even if we have the negative or the positive values of the v, we have always in the reverse direction of the what? Of the position, because we are going to somewhere, okay? So we can conclude that the so the fx is conservative force, or fx is equals to minus dv dx, but this v is a bigger v, is the energy, okay? Because it's always in the reverse direction of these terms, okay? If we push or the what carry to this m to the v, and so in the universe this v is what? Is diminishing, but the potential one is greater with respect to what? With respect to the O value, okay? Otherwise we cannot do that. And so it's in the another definition, it's the reaction of origin or the reaction energy in a basic meanings. Because if you have any kinetic energy one, if you have this process, these things, and so this is what is always going outside or out from the what? From the O value in here, or the origin space, right? And so if we have this information, and so if we have any static system in here, if we have dynamics, and then just like the reaction force, we should equalize or the balance this kinetic energy with one other energy, which we call it to the what? Potential one, okay? So the potential energy can be called as to what? Is a reaction energy for the kinetic one. Because in this case, we have pushed the what? The table. And so the reaction is happen. But if the reaction does not happen in here, and so it moves, okay? And so if it's still in here, and so it includes the what? The potential one. Because it has a spring factor in here, okay? Just like these terms. And so if this is our the equation, and then we x is equals to what? dv, and also minus fx dx, and then we can say that in this formula we get 1 divided by m v square plus vx must be equals to what? To the constant values, okay, in here, because this is the kinetic one, this is the potential one. But what is the meaning of the C? Huh? Who is talking? Huh? Yes, it's the unchanged energy. This is also called what? The preserved energy. Huh? Yes, unchanged mechanical energy. Okay? So we can preserve our system based on these informations, guys. Okay? So okay. So this is the case 2.21, calculating the inertia here. Okay, so the mass moment of inertia, has anyone remembered this equation? Around reference axis. Just remember that if we have the I value in here, and so, huh? No, this is the integral form. No, r square times dm. Just remember that. And so, what is r value? If we have the any objects in here, and then the r can be built by using this one, right? But under this condition, the conditions is that this is the homogeneous rigid body. Okay? So if we have the any values in here with the I, and then just remember that if we have the inertia value of these terms, we preserve what? The our rigid body, right? Our rigid body. And so I have the internal inertia because I need to preserve my body. But if I choose the any point, for example, for this one, I can rotate this value at what? At the center of gravity. And so I have the internal point. But if I choose the points, the rotate these values, and so we have also another inertia value. Just remember that. Remember that, Hajar? Yes. And so we always calculate this value I with the what? The IS. This is the internal shape inertia times m times d square from this integral. And so the IS is the internal value, BH cube divided by 12, it's equals to this one. And so plus m times r square, which is coming from the what? The parallel axis theorem. Okay? And so in order to analyze or to evaluate your response, this is the what? The internal inertia. But this is to what? Inertia coming from, huh? Coming from, huh? External force, but just the, if we assign these O values in here, and so coming up around O rotation, right? We can rotate this one, and also this can be rotated at around, right? And so we have two inertia factor to be calculated in here, right? Except from what if we consider that this is the what, for example, the particle. In the particle, which one is removed? Huh? Ne? Yes, because yes, but we have m times r square. Why? Yes. Thank you. So, you get it? What's your name? Yes? Name? Mentella. Do you understand that your friends said? Okay. So, what about this one? We can write to the what? To the examples in here. Example, and show the pendulum consists of to what? Mass and rod length L. Okay, so we can build the what to the fixed point just like this one. And so if this is the fixed point, and then we should assign, or we should call it to the what? Yes, because it's a fixed point. The rigidity of this system is coming from the what? This fixed point, guys. Okay? We should always assign the fixed point to the what? To the R origin. We can change the origin, but in the fixed system, in this system, we should take it because we can referate this value. We can calculate the position, not the relative one, the absolute one, if we have any fixed position in here. Okay? So, if we have this value, and so we can build what? This is the M. Okay? And so we have also to what? To L in here, and so we should define what the theta value in here. This is the degree deflection rate. Okay, and so our problem is that solve and obtain equation of motion. Okay, solution can be done with the what? First of all, using the Newton principles. We must write that rotational or the translational one should be included in this system. Why?
Because the angle.
Yes. Which kind of motion is happened in this system? Huh? Both motions, but around the O point, only rotational one is happened. And so, from this rotational motion, we can write the translational motion. At the what? If we define the X and Y. Just like this one, but we don't have any axis position in here, just like this one. Okay, and so we don't need to do that. So all the torque values or the moment values must be equals to the what? I0 times W dot, which means that W is the angular velocity values of these terms, and so I0 is equals to what? Theta dot dot, right? This is the second derivative of the what? The angular positions, guys. Okay. And so we need to calculate what the total moment values applied on this m value in here, right? And after that, we can equalize to the what? The acceleration term of these terms. This is called the Newton's principle or Newton's solution for the what? The mechanical systems. Okay. So how we can write this value? First of all, we have the g value in here. This is the gravity. And then we can put the what? Create the two forces in here, just like this one. One of them is the mg cos theta, and the other one mg sin theta. Okay, and so in order to create the moment, which one should be used? Yeah? Yes. So the moment equation, or the I0 theta dot dot, must be equals to the what? M G sin theta times L. This is correct? Is this correct? If we have this solution, and then we need to take a look at the what, to the direction of this force and the position. What's your name, guys? Mehmet. Adaşım. Mehmet. The direction of the theta and the mg sin theta is proportional or in the reverse order? Is in reverse or the direct in here? Just see that.
Theta decreases,
Mm-hmm.
mg sin theta increases, so they are reverse proportional.
Yes. And so if we rotate the m position in here just like this one, but this force reacts or resists to what? To turning at this direction, counterclockwise, right? And so this must be equal to what? The minus, right? Everyone gets that? This position? Okay. And so how we can calculate the inertia of the system? Nasir? Huh? How we can calculate the I0? I0 is equals to the what? Who is that? Huh. What's your name again? Sarah. Sarah, could you tell me again? Yes, ml square. But why? Because we don't have any mass point in the road. This is the approximation. Okay? And so, if we have the origin value at O, and then we can rotate the m with the length of the L. And so we can create the inertia values in here, which is resisting or the acceleration terms on the what? On our pendulum system. And so, if we rewrite this equation just like this one, and so m L square times theta dot dot must be equals to what? M G L sin theta, right? And also we can say that theta can be considered with what? Sin theta in here to be what? The linearized on our system. Small angle approximation, right? And then we can write this equation just like this one. L times theta dot dot is equals to the minus g times theta, or in summary, theta dot dot is equals to what? Minus g L times theta, right? So what's the conclusion of this system? We have second order derivative and no order derivative in here, right? But just see that we don't have any m value in here. What does it mean? Huh? It is on? Yes. And so if this is the case, just see that. Just see that. Just remember to what? In S domain, Nasser, what's this domain? Just tell me. Be loud. Be loud. Huh? Laplace. Who is Laplace? Say any football player or Kim? Who? French. Yes. Okay. And so this French mathematician professor, physicist, okay, and so gave us two beautiful way to what? To define the what? Dynamic system in terms of what? Algebraic one, right? And so we can apply the what? S domain in here. And then S square times theta S minus S theta 0. We have the initial condition and minus theta dot 0, which is equals to the what? Minus G divided by L theta S, right? This is the what? The Laplace solution for this system. And so this theta S can be rewritten as to what? S times theta 0 plus theta dot 0 S square plus G divided by L. See? Remember this formula from the previous week? It's called to the what? Nasser? It's called, yes, natural frequency. Okay. And so, what is the root of these terms in the first place? We should always check to the what? To the roots, because the roots is what? Our time constants. Okay. And so S1 and 2 must be equals to plus minus, because we have the two roots in here, and so J times G divided by L, right? Or this is equals to what? The J WN, right? And so this natural frequency does not depend on the what? On the M value, right? And so the dynamicity or the equation of motion does not depend on the what? On the mass change. We are using the what? The 1000 kilogram or the 1 kilogram. We will have always same natural frequency in here. In this case. Yes, Mantella. You have any question? Okay. And so, how we can solve this equation? We can write theta S is equals to what? The S times theta 0 divided by S square plus WN square plus theta dot 0 divided by S square WN square. And so, in the time domain, can use the what? The Laplace transformation table in here. Theta 0 times cosinus Wn times t plus theta dot 0 divided by Wn times sinus Wn t. Okay? This is our solution of the what? Of the system. Okay? Any question?
And in such a system, are we responsible for the oscillatory motion?
Yes. We will always have the oscillatory motion, not the losing the energy or increasing the energy. We always oscillate. But if we want to utilize what the 1000 kilogram or the 1 kilogram, this oscillation does not change. If we have, just see that, if we have this the 1 kilogram, if we have the deflection rate 30 degree in here, 1000 kilograms have also 30 degree. Why? Because we have the same roots in here, the same time response in here. Okay? Any question? So, if there's no question, and so we will take a break here.